Hi guys, today we're going to look at a little bit more flow control. We're going to go back and specifically look at if, elif, and else statements, and we're going to look at the and, or, and not modifiers. So go ahead and let's go to the desktop. Okay, the first thing you want to do is open up Notepad++. And once we do that, then we're going to, no, we don't want to download an update package right now. We're going to get rid of what we had last time, and we are going to save our new file for today. I'm going to save it as number 11. So Python exercise number 11. Save that, and then we're going to open up our command line. Change over to the correct folder, Python code, and make sure in our directory that we have the number 11. There it is. Okay. All right. So we should be ready to get started momentarily. So let's go ahead and look at these conditions here. All right, so we should be ready to go ahead and let's get started. We're going to start with just a simple if statement, and then we'll go from there. Should be familiar with the if statements, but we're going to emphasize the indentation. Indentation is what Python uses in place of curly brackets. If you study Java, or if you study C++, or some of the other programming languages, in order to designate a block of code like a method or a function or whatever, they use curly brackets, opening and closing curly brackets. Python does not, but it does use indentation. So that can be a blessing or a curse. I can tell you as a Java programmer, closing and opening curly brackets, and particularly if you have a lot of them nested, you're going to find that you're going to miss one, or you're going to have one too many. They won't match up, and that can be a pain. The indentation gives you a more visual cue, but like I say, it can also be a problem, because if you don't have the same number of spaces in each indent, things like that, then you can also get yourself in a mess. But regardless, we're going to go ahead and look at an if statement, just a simple if, and based on its results, we're going to print something to the console, and then we'll move on from there. So to start off, of course, we need to declare some variables. That's the first thing you always do. We're just going to use A and B for right now. And we're going to say A is equal to, I'm going to say 10, and B is equal to 2. So A is 10, B is 2, and we're going to start our if statement with the word if, lowercase. If A is greater than B. Now, in other languages, we would put then, the word then, but in Python, we use a colon. So that colon represents the word then. And then we take a space down, and then we hit the tab key because we have to indent. So if A is greater than B, we're going to print A is B, which makes perfect sense. All right. And notice then we ended our program here. This will be the last line. So what I'm going to do is I'm going to print program ends, just to show you that what you need to do after you're done with the code that runs the if statement, then you need to unindent. You need to go back to the original margin to continue on with your program. So let's go ahead and save that. Let's see if it will behave itself. So I'm going to run Python or 11.py, and sure enough, notice, because A was 10 and B was 2, A is greater than B. And then we went to the next line. Our if statement ran, it did what it was supposed to do, it ran its code, but then the program resumed, and we printed out program ends. Let's go back and analyze it. We set up our variables here. A is 10, B is 2, If A is greater than B, colon, that's the then it is, because 10 is greater than 2, then we print it out, A is greater than B. Now, we are done with our if statement, and so our next line of code goes back to the original margin, and this is where your program would continue on if you had other lines of code in there. So then we print program ends. So what happens is the if statement runs, it either does something or it doesn't, and then after the if statement, the program resumes and the code continues to run. And then if we wanted to put another if statement in there, we could put another if and then indent some more. And we'll look at some of those things shortly. But remember, indentation is the key. If we don't indent, if we just leave it all in line, then what we're going to get is an error. So we're going to run this just to see the error. So I'm going to get an error there if I don't do that. Okay, so you cannot run an if statement without an indented block. If there's code after the if statement, then you have to indent. However, there's a thing that you can do to avoid that. There's a shorthand for writing if statements. If you just have one simple line of code, or if it's a simple if statement like this one, for example, what you can do is you can make this all on one line. And to do that, we're basically going to do that. Now, at this point, you don't have to indent because it's all on one line, but it should run exactly the same. So let's go ahead and run it. And sure enough, it runs exactly like it did the first time. So if you have just one line, or it's a real simple if statement, you can actually do more than one line here. But this is just a kind of a shorthand way of doing an if statement. That makes it simpler. We'll look at shorthand if-else statement shortly, but for right now, just know that you can do this without the indentation. Now, here's the drawback. Here's the caveat to that. If you do this without the indentation, it's very easy to get confused on where you are and what kind of code you're going to run after the if statement. Also, you can only run just simple short lines like this. You can't have a complicated code block after your if statement, and a lot of times that's going to be the thing. This is if you just have a real quick need to make a decision in the program real fast, then you can put it all in one line. But for the most part, you're going to have lots of code based on the if statement that needs to be in the code block, and so you're going to need to use indentation. You will use indentation a lot more than you'll use this shortcut, but just to kind of keep you honest on that. All right, so most of the time, you're not just going to have a one-shot decision like this. Most of the time, you're going to have multiple conditions, or you're going to want multiple results out of one condition. And so that's what we're going to look at right now. Let's say we have 2 or 3 or 4 more possibilities. All right, so what we're going to do, we're going to go back to our original tab key. There we go. Going to go back to our original deal. A is greater than B, and then we have our indentation. Now, we can also use what's called an else if, or elif. And basically that's what it means. It's another way to add more conditions. So elif A is equal to B, and remember we decided last time that the double equal sign was a comparison, it wasn't an assignment. Elif A is equal to B, then we make another code block. And we're going to say print A is equal to B. And then we're going to do our program ends here. Just to get an idea of how this works and that you can continue on with more code. Save it, run it. And sure enough, A is still greater than B because it's still 10 and 2, and the program ends. So nothing happened in our elif statement because these two are not equal at all. Now let's change and let's make this one equal. Let's see what it does. Okay, now that A and B are both 10, we can see that A is equal to B, but the code still keeps running just like it's supposed to. The program block ends and then the program continues on. So essentially we can add as many elif statements as we need. For example, if we wanted to do this, elif A is less than B, and we're going to print, oops, I'm going to do that, A plus E. And we're still going to leave our program ends block down here. But now there's a possibility for anything to happen. All right, and so we're going to change it so that A is in fact less than B. We're going to save it, run it, spell it right. A is in fact less than B, and our program keeps running. So basically that is how we can have any number of possibilities. Now let's do one more thing here. Okay, we're going to add one more condition, and we're going to say if A is not equal to B. Now this is going to be tricky. Oops. Okay, so we've got a fourth condition here. Save it, run it. All right, now you notice it still says A is less than B, but we also see that A is certainly not equal to B. So why didn't this one run? Well, when you have a collection or a selection of decision programs like this, and they use this else if, this is all considered to be one logic flow control structure. This is all one thing. And so in an if statement, it will only do one thing, and it always picks the first one. It picks the first one that's true, it runs that code, and then it stops. It goes on to the rest of the program. So it will only do the first thing. So if you wanted to also determine that A was not less than B, then what you'd have to do is change this from an elif statement to an if statement. So now we have two separate logic control sections. We have this, we determine the value of A compared to B, and this, we determine whether they're equal or not. Let's save that. Now we should get three things printed off. And sure enough, A is less than B still, 2 and 10. A is certainly not equal to B, 2 is not equal to 10, and then the program continues on. So, in an if-else statement, the only thing that can happen is the first thing that's true. It goes through the code, and when it hits upon a true condition, it runs the code in that block, and then it moves on to the next thing. Now, if that next thing happens to be another if statement, then it makes that decision, and then it goes through the code in that block. If the next thing happens to be the rest of the program, it does that. But it's important to realize that if you're using an if, and I could have had 50 else if statements in here, it would have gone through until it found the first one that was true. It would have done the code in that block, and then it would have jumped all the way to the rest of the program, which would have been here. I hope that makes sense. So, if you have more than one decision, you need to make more than one if statement. You can't just stick a bunch of elifs there. You need to decide if this is part of the original decision making or if this needs to be a new decision making, and in this case it was. All right, there's one other word we want to look at, and that's the else statement. And basically what that is the last decision option of a logic block. So we've got if, else if, and then finally, let's go ahead and get rid of this one. We don't need it in there. We made our point. Then we're going to go else, colon. And this means that in all other cases, so you don't have to have a conditional here. You don't have to say if A is less than B or A is greater than B or anything like that. You can just say this is it. I'm going to go ahead and get rid of this one too. Okay, there we go. But we do have to have the colon, and we do have to do the indentation. So the other option here is A is less than B. All right, and this works the same as an else if, only the only difference really in these two is that this else if has another possibility, whereas else accounts for all of the possibilities. It's a good programming practice to put an else statement at the end of every if statement, because what can happen is you might have some other condition that you forgot to take into account, and this takes that into account automatically, whatever it is. So let's go ahead and run. Remember, A is still less than B, so we should get our last option here. Oops. And sure enough, we do. A is less than B. That's the other unnamed option. That's the only other option. And then the program ends because we've gone on to go on to the rest of our code here. So that is basically how the if, else, and else if statement works. Now, I'm going to get into a little more real world stuff, because you're almost never going to have just one tiny little isolated condition. So we're going to say C is equal to 5 and D is equal to 3. And in this case, we're going to use the AND statement. Okay, so the AND statement means that both of the conditionals have to be true. So I'm going to say if A is less than B and C is less than D. And we're going to say both A and C are bigger. Okay, so now if A is greater than B and C is greater than D, and I'm going to change this so it's true this time. Our little statement back in here that shows that we go on to the rest of our code. Do that. Sure enough, both A and C are bigger because 12 is bigger than 10, 5 is bigger than 3. So indeed, both of these are true. Now, if I change one of them, if I make this a 6, say, so now 12 is greater than 10, but 5 is not greater than 6. I'm going to go ahead and run that, and let's see what it does. We get nothing, but our little program ends. So what happens, Python's interpreter comes in, it examines the conditions, it says, nope, this one's not, or yes, this one is, but no, this one's not. Well, the AND statement requires that both be true, so instead of doing anything here, it just skips the code block because neither, this condition is not true. And so that's required for the AND statement. So let's go ahead and look now at the OR statement. So I'm going to change this to OR. And remember, we said a while ago, that the and statement required that both things be true. Well, the or statement requires that either A or B is true. And so, let's see, different. In this case, A is true, but B is not. However, I think it's going to print. Let's change this to make more sense. Basically, one or the other of these things has got to be true for this to work. Save it. Right. And sure enough, one or the other is true. In this case, A is true. The first A is greater than B is true. C is not greater, but because we have an or statement, this works for us. Now let's try one other little caveat here, and we're going to look at the not statement. Okay, so not goes in front. We're going to say not. What this says, if not A greater than B, that means B needs to be greater than A, or C is greater than D not, that means, well, actually, let's just go with the first one. Don't try to add them together for right now. We'll get back to add them together in a second. For right now, if not A is greater than B, we're going to print A is less than B. We don't want to confuse things right now. So what this basically means is the opposite of what the conditional. If the conditional's opposite is true. Save it. Run it. And the opposite is not true. A is in fact greater than B, so the opposite of that is not true. And because it's not true, we can't run the code block. Just go to the end of the program. So we can cancel out these conditionals by using the not statement. What we can also do is make big, long, complicated strings out of them. And not, let's see, B is equal to C. How about that? What I'm saying here, if A is not greater than B, and B is not equal to C, then we're going to print. So, what can we do? Let's save it. Let's run it. And, nope, we didn't. Okay, let's analyze the code. A is definitely greater than B. So if not that, that would mean that B was greater than A. And not B is equal to C. So we know both of these are not true. Both of these are false. Well, actually, no, hang on. We know this one is false because A is in fact greater than B. C and B are not equal, so this one would be true, but this one would not. But the AND requires that both of them would be true, so that's why we skipped the code block there. So as you can see, this can get a little complicated, and so it's very important to keep track of what you're doing. It's very important to, sometimes it's important to diagram the logic that you want this to flow. You can draw a chart. Basically, you can draw a outline or diagram of your program, because if you don't, you can get confused very fast. Also, it's a good idea not to convolute this like this. If we wanted to do this, the easier way would to get rid of these knots and turn these around. This would be a lot easier. And it would basically give us the same result. So if we save that and we run it, so you want to simplify as much as possible. See, we still get the same results because, in fact, A is not less than B. That automatically kills our AND statement. That automatically prevents us from running our code block, and we just go to the end. So as you can see, it can get complicated. Things to remember: use the simplest possible clues, or the simplest possible combination of modifiers that you can use. Simplify everything as much as possible. Don't say, if not and or this, that. No, you don't want to go there. Make this as simple as possible. All right, it's also possible to nest if statements. Now, this can be complicated as well, so let's go ahead and, all right, so if A is greater than B, or pardon me, let's make that greater than. So if A is greater than B, then we're going to tab over and we're going to say if A is greater than C. And then we're going to tab over and we're going to go print A is larger than B or C. That's what we're going to do. So basically, it's going to look at this, and if that works, it's going to go to the next line. It's going to look at that. If that works, it's going to go down to this line. This is equivalent to saying if A is greater than B and A is greater than C. But you can also put in here code. And this is where this comes in useful. All right, so we do this. If it's true, we go here. And if that's, and once that runs, then we go here. If this is not true, we go all the way down to here. All right, so let's run it and see what happens. Okay, and sure enough, because all the conditions were true, we ran all the way through the statement. Since A is in fact greater than B, we printed what we had to print. And then we went to the next line, which was an if statement. If A is greater than C, which it is, then we printed that as well, and then we went to the end of our program. Now let's change this first part. And we're going to make this back to 2 again. So now the first part is no longer true. Let's see what happens. Whole thing skipped. We went all the way down to the end because when we evaluated this first if statement, none of it was true, so that means we never entered into the program block, which means we never got to this if statement. So let's go back up and make this back to 12, so this first part's true, but now we're going to make the second part 15. So the second part's no longer true, so let's see what happens next. So we only ran the first part. We only ran the first part because the second part was not true. So we evaluated the first if. It was true. We ran the code. We hit the second if. We evaluated. It was false, so we skipped to the end. And that's what we did. So basically, these are nested if statements, and you can get very complicated in nesting if statements. The problem with that is you have to remember what level of work you're on. That's why this indentation process is very handy, because it can give you a visual cue as to what level of if statement you're working on, whether you're in this one, whether you're in this one here. It will tell you, oops, pardon me, that one there.
it will tell you what level of the if statement you're working in. So if you're going to nest those, it's very important that you keep up with where you're at. Okay, now let's say you have two if statements. Let's go back to two if statements here. Okay, so if A is greater than B, then we're going to print A is greater than B. Okay, simple enough. Well, actually, we're not going to do that. What we're going to do is we're going to pass. Okay, that's the other thing I wanted to show you here. Let's say we only want a response if this is the case. Well, actually, I want to go more into detail on that. Let's go back and print. We're going to do two statements here. All right. All righty. So if C is greater than D, pass. When would we use this? Well, when we had the second statement depending on the first statement, or there was something else depending on the first statement and the first statement didn't go through, then we would pass. And so basically what a pass means is we just jump to the end regardless. And so I'm going to print it out down here. Jumped to the end. All right. But you cannot have a blank code block. If you need to have a blank code block, you need to put something in there, and that something is pass. Because if you put that in there, it means we can jump to the end, and we don't have to worry about it. Save it, run it. And we do know that A is greater than B, so we printed that. And then C was in fact greater than D, but we didn't do anything about it, we just jumped straight to the end. And so that's what pass means. You can't have an empty code block after an if statement, but you can put pass in there, and that basically is like playing cards. You just pass. You move on to the next thing, and essentially you don't have to worry about what you did or didn't do. There's nothing in there. This does not impact the program at all, other than the if statement evaluates, and then when it hits the word pass, it moves on to the next line or to the end of the if statement. So that's basically where we're going with that. All right, guys, hope that was helpful and not too terribly confusing. Go ahead and do the exercises. Complete that. When you have the code working to your satisfaction, use the Start Assignment button to turn it in. And once you've got that done, then we'll move on to the next bit. Hope to see you in class. Have a good day. And remember, if you have any questions, I can be reached at whiter@grayson.edu or through the help icon in through the inbox in Canvas. If you have any questions, send me a message, and I'll see you in class.